correction dekat nota kita. 4.1 we already done, right? 4.1 kan? 4.2 extremum problem. Asalnya dalam nota anda adalah curve sketching, betul tak? You open your notes, class.
Yes, madam.
Okay. So reason your current notes is written 4.2 curve sketching. Tolong tukar jadi extremum problem. Tukar jadi extremum problem. Dan objektif kita ada 3 untuk subtopik ini. First objective is to find the stationary points. Just check your notes. If there's any different, tolong buat correction. B though, the second objective is to identify minimum and maximum points by using the first and the second derivative test. And the C is a soft optimization problem. Tolong buat correction now. Open your notes, turn to the 4.2. For your notes, it's written 4.2 curve sketching. So now change to extremum problem. Change to extremum problem. Okay, and we have a 3 objective under this subtopic. The first one is to find the stationary point. Second, to identify minimum and maximum point by using the first and the second derivative test. And the third objective is to solve optimization problem. Done? Have you all done?
Yes.
Okay. So firstly, I will go for stationary point. Stationary point in bahasa Melayu kita panggil titik pegun. Okay, kita boleh panggil ini sebagai titik pegun. Titik yang dia henti sekejap. Okay, so when you're driving, you go, okay, you drive to the forward, and then bila you nak U-turn, you will tekan brake, betul tak? You akan tekan brake, lepas tu baru you U-turn. Okay, then the titik di mana kamu buat U-turn itu, yang kamu henti sekejap itu adalah stationary point. The point where the f prime x equals to 0 and the point x equals to c, itu adalah stationary point. Meaning that if you want to get the f prime, you want to get a stationary point, you akan cari dy dx dulu ataupun f prime x, and then you let the f prime x equals to 0. Then you solve. You solve. Then x you dapat apa? Itu adalah nilai di mana is a x coordinate when titik pegun berlaku ataupun stationary point happen. So in other words, you can say that f prime c is equal to 0. F prime c, what does it mean by f prime c? It means that you substitute the value of c, x equals to c, into your f prime x. All right, then it equals to 0. This shows that the stationary point happened at the x equals to c. Okay, so why we say that the f prime x is equals to 0 when it happened at the stationary point? Because stationary point adalah macam tu. Kalaulah kita ada curve macam tu, kita naik sampai kita nak turn ke bawah tu, kita akan henti sekejap. Bila kita henti sekejap tu, itu titik itu kita panggil sebagai stationary point. And when you draw a line, a tangent through touching the stationary point, this is a tangent, you will see that the tangent is actually a horizontal line. Because of it is a horizontal line, meaning that its gradient will be equals to 0. Because the dy dx showing the gradient. Okay, dy dx adalah menunjukkan gradient bagi tangent line. So dy dx equals to 0, dia berlaku pada garis ini sebab garis ini adalah satu garis horizontal. Okay, dan titik itu kita boleh panggil sebagai stationary point because dia naik, you punya graph naik, lepas dia henti sekejap, baru dia turun. Okay, this is called the stationary point. Okay, consider this diagram. I have 3 points over here, A, B, and C. A, B, and C, you can see that the line all are the horizontal line, and this shows that the dy dx is equals to 0. Bagi titik C special sikit ya, Titik C adalah satu inflection, point of inflection. But here you are not going to learn in detail what is a point of inflection. Okay, you hanya akan belajar titik maksimum ataupun minimum later on. Tapi titik C ini sebenarnya for your information, point of inflection juga adalah dy dx equals to 0. Dia boleh berlaku. And this is also called the stationary point. When you have a line like this, a gradient at this point, dy dx is not equal to 0. Very obviously that this is not a horizontal line. So you will know that dy dx is not equal to 0. And titik ini yang dipanggil D itu dia bukan stationary point. The A, B, and C are called stationary point. Why we say so? Because the dy dx equals to 0. As a conclusion, stationary point happen when the dy dx equals to 0. When the question asking for the stationary point, first thing you must remember is dy dx, and then let it equal to 0. From there, you got your stationary point. Kita ada beberapa jenis stationary point. Stationary point can be a maximum, can be a minimum, or can be a point of inflection. Point of inflection, again, we're not going to learn in detail. Okay, this will be learned maybe, next year. Okay, next year. Then kita nak belajar untuk sekarang ni adalah untuk maximum dan minimum sahaja. Minimum and maximum point also called as an extremum point. You all know what is extremum? Maksud extreme sangat besar ataupun sangat kecil. So extremum point also refer to maximum and minimum. How do you determine the maximum point or minimum point, or we say extremum point? First thing, get your dy dx. Get your dy dx first, and then let it equal to 0. From there, you selesai. After you solve, you get x equals to apa? C contohnya. Lepas tu, C itu, adakah dia maksimum ataupun minimum? It's a question mark. So how do you determine either x equals to C adalah x coordinate untuk maksimum ataupun minimum? Then kita kena pakai first derivative test ataupun second derivative test. Depends on the question. If the question did not say pakai which test, then you boleh pakai either one. Tapi kalau soalan kata use the first derivative test to find the maximum or minimum point, okay, nature, to determine the nature of the points, the extreme point, then you kena pakai cara itu, yeah. So later on, we're going to see both methods. Firstly, get your stationary point dulu. Find the stationary points for this function. So to find a stationary point, we need to find dy dx first. Get your dy dx, that will be 3x squared minus 6x. Okay, then dy dx equals to 0. Kita akan let the dy dx equals to 0 in order to solve for the x yang di mana stationary point berlaku. Okay, then for this question, for this equation, to solve it, we can factor out the 3x. We have x minus 2 equals to 0. So we got x equals to 0, x equals to 2. All right. So since the question asks for the stationary point, meaning that it needs a y coordinate as well, get your y coordinate, corresponding y coordinates. So when x equals to 0, what is the value of y? Y is 0 minus 0 plus 6. That will be equals to 6. And when x equals to 2, y will be equals to 8 minus 12 plus 6. That will be 2. All right. So now we have a 2 point. The first point is a 0, 6. And 2, 2 is both point, we call it as a stationary. Okay, stationary point happen when the dy dx equals to 0. This is just a you need to remember this one. Okay, dy dx equals to 0. We find the points using the dy dx equals to 0. So we have a 2 stationary point over here. All right, this is the way we get a stationary point. And for the second question, same method will apply. Get your dy dx first. Because question asking for stationary point kan. Kita cari dy dx dulu. Bring the 1/3 to the front. and then provide a bracket. Bracket itu adalah untuk inner function. Kuasa tolak 1 dapat negatif 2/3. And then inner function salin balik. Darab dengan differentiate the inner function, you get 2x. Alright, simplify, you get 2x over 3 x squared minus 1, 2 over 3. Okay, to get a stationary point, kita akan let dy dx equals to 0, then we solve. Dy dx sama dengan kosong. Daripada sini, kita dapat x sama dengan kosong. When x equals to 0, apakah nilai y kita? Y is a 0 minus 1 power of 1 over 3. That will be cube root of negative 1. That will be equals to negative 1. Means that our stationary point is 0, negative 1. We have only one stationary point for this question. Alright, so this is how we get the stationary point. And now we are talking about the first derivative test. Okay, untuk relative maximum. So maybe some of you will curious, why not we call as a maximum point only, not relative maximum point? Relative, what is the meaning of relative? Relative means that you are actually compared to others. Compared to others, then you got the relative value. All right, so let's consider this diagram. Okay, this curve. Can you tell me where is the maximum point? Okay, some of you may say, this is the maximum point. Then some of you will say, okay, no, this is not the maximum. Here, I have a higher point, which is higher than this point. So I call this as a maximum. It's not true also, because some of you may say that I have a higher point than what you all said. Okay, I have a higher point over here. So is this a maximum? It's not true, because our graph is keep on increasing. Okay, there is no maximum. Maximum is infinity. All right. So why we call this this point? How we call it? How we call this point? We call this as a relative maximum. Why we call this as a relative maximum? Because it compared to the point nearby. Compared to the point nearby over here, it is a maximum. So we call this as a relative maximum. And we have another term which is a relative minimum point. Why we call this a relative minimum? Okay, it's over here, the relative minimum point. And why we call as a relative minimum is not minimum point? Because minimum point, this point is even lesser than this point, lower than this point. So we don't call as a minimum point. This point we don't call as a minimum point, because there is some points, many points, infinity point is still lower than this point. So we cannot call this point as a minimum point sahaja. Kita kena panggil dia relative minimum point, because it compared to the point just nearby, it is a minimum. So we call as a relative minimum point. The word relative is come from here. Okay? Is that clear, class? Boleh?
Boleh, madam.
Okay. So untuk apa? Untuk kita punya ni first derivative test, sebenarnya kalau kita ada maximum point, kalau kita ada relative maximum point, kita tahu dia mesti dekat apa relative maximum point, dia punya dy dx mesti kosong. Dy dx kosong, kita selesai, kita dapat x sama dengan c. We solve. We let our dy dx equals to 0. We solve. We got our x equals to c. Then we know that this is either maximum or minimum. Then we check the value, which is in the left-hand side, at the left-hand side of the x equals to c. Kita cari. Kita ganti satu nilai yang kurang daripada c inside our dy dx. If we got the dy dx is greater than 0, meaning that gradient greater than 0 means that our graph is increasing. Increasing is from the left to the right. From the left to the right is increasing. So, bila kita lukis secara apa? Using diagram, ini adalah gradient dia. Ini adalah garis dia. Okay. Dan kita juga akan ganti satu nilai yang lebih besar daripada C, iaitu di sebelah kanan X equal to C. Bila kita ganti X yang melebihi C itu, masuk dalam dy dx, kita mendapati dy dx itu adalah less than 0 or negative, means that our gradient is going down, is decreasing. Decreasing. Y is decreasing. Meaning that kita punya graph bentuk adalah macam itu. You akan nampak naik, pegun, turun. Then, bila kita lukis graph, you akan nampak, oh, titik ini sebenarnya adalah relative maximum. Okay, later kita akan tengok contoh. Lagi first derivative test for the relative minimum point. Firstly, same thing, you get your dy dx, you let your dy dx equals to 0, then daripada situ you selesai. You solve, you get that x equals to c. Then you tahu ini adalah satu extremum point. Either maximum ataupun minimum. Kita tak tahu lagi. Ya, tak tahu lagi. Then kita masukkan satu nilai x kurang daripada c. Satu nilai yang kurang daripada c masuk dalam dy dx. Masuk dalam dy dx. Apabila you dapat dy dx nilai itu adalah kurang daripada kosong, iaitu negatif, meaning that your graph ataupun bentuk you y di sebelah kiri extremum point itu adalah menurun. Y is decreasing. Then lepas tu you check dia punya sebelah kanan pula. You ganti satu nilai x which is greater than c. Substitute into your dy dx. If you got the value is greater than 0, which is all you say the positive, meaning that the gradient of the tangent at the graph, okay, which is greater than c, is increasing. Your y is increasing. So if you consider three of the line, the three line over here, if you just follow the line and you slightly sketch the graph, the curve, you will have minimum. You will know that this point is actually is a relative minimum. Okay, ini adalah konsep dia. Kita cari dulu dy dx equals to 0. Daripada situ, kita menentukan extremum point dulu. Then di kiri extremum point dan di kanan extremum point itu kita kena check dia punya apa? Dia punya dy dx. Lepas tu kita lukis dia punya pattern. Daripada situ kita tentukan dia maximum ataupun minimum. Dan second derivative test lebih senang nak faham lah. Okay, you get your dy dx equals to 0. From here you selesai. You solve for the x equals, you solve and then you got the x equals to c. You know that the stationary point happen when the x equals to c. And then you do not know either this x equals to c is a relative maximum or relative minimum. You do not know. You check with the second derivative test. You find the d2y dx2. Cari d2y dx2. Kalau d2y dx2 itu adalah negatif, maka ini adalah maximum. Tolong buat correction. Ini adalah maximum. Maximum point. If your dy dx, when you substitute the x equals to c ke dalam d2y dx2, you dapat less than 0, means that the point c, fc is your nilai y when x equals to c, okay, is a relative maximum point. And if your d2y dx2 is greater than 0 when you substitute the x equals to c inside, then that point will be the relative minimum point. Okay, this is the second derivative test. Dia lebih apa? Dia tak payah lukis table. You just calculate and then consider the sign. Okay, so now we have a question. Find the relative maximum, relative extremum point for the function. This function is the same as example 1 by using the first and the second derivative test. So what is the step to determine whether this is a maximum or minimum? Firstly, get your dy dx. Okay, and then let your dy dx equals to 0. The same method, all the steps are already shown in the example 1 because the function exactly the same as example 1. Then you factor out the 3x, you solve, you got the x equals to 0, x equals to 2. All right, again, here is a mistake. Here should be 2. When x equals to 0, y equals to 6. When x equals to 2, y equals to 2. Okay, you find the corresponding value of 1. Meaning that, okay, the extremum point happen when x equals to 0 and x equals to 2. So to use the first derivative test, I will check the first point dulu ya. Kita check point yang pertama, iaitu x sama dengan kosong. Okay, when x equals to 0, I will write when x equals to 0. I will test the point, okay, because kita ada dua titik extremum point, maka kita akan check point by point, one by one. I will check my point one by one. First, I will check when x equals to 0. When x equals to 0, saya lukis satu table. Ada 4 kolom, 3 row, 4 column and 3 row. Alright, this is a point that we want to check, iaitu x sama dengan kosong. Ini adalah nilai x lah ya. Dia punya title nilai x. Then ganti satu nilai yang kurang daripada kosong di kiri. Ganti satu nilai yang lebih besar daripada kosong di kanan. Okay, kita check when x equals to 0 dulu. X equals to 0, kiri ada nilai yang kurang daripada kosong, kanan ada nilai yang lebih besar daripada kosong. And then I check my dy dx sign. Ganti satu nilai di mana kurang daripada kosong, contohnya ganti negatif 1. Ganti negatif 1 ke dalam dy dx. Dy dx kita adalah 3x square minus 6x. You ganti satu nilai yang kurang daripada kosong, contohnya negatif 1. Masuk dalam sini, what do you get? Negative 1 square, you get positive 1. Positive 1 multiplied by 3, 3. 3 minus 6 multiplied by negative 1. Jadi 3 plus 6, you dapat positive. Tanda dia aja. Nilai tak penting. Nilai tak penting. Dan memang apa? When x equals to 0, you ganti x equals to 0 ke dalam sini, memang dapat kosong. Memang dapat kosong ya. Memang x equals to 0 tu kita selesai daripada dy dx equals to 0. So ini memang kosong di tengah-tengah. Dan ganti satu nilai yang melebihi kosong, contohnya ganti 1. Ganti 1 masuk dalam sini, you dapat 3 tolak 6, dapat negatif. Then what do you see for the y? For the y pattern. Pattern of y. Okay, pattern of y. Maksudnya, dy dx adalah gradient, mewakili gradient kan? So, kalaulah kita dapat positif, pattern of the y dia naik. Gradient dia naik. Positif maksudnya dia naik. Kosong maksudnya dia horizontal line. Negatif maksudnya dia turun. Pattern. Then if I slightly sketch the graph according to this three line, according to 3 lines here, I slightly follow them and sketch a graph curve. I dapat macam itu. So what do you think? Titik x sama dengan kosong itu adalah maksimum ke minimum, kelas? Relative maximum ke relative minimum?
Maximum.
Relative maximum. From the line, from the pattern that you have here, tiga-tiga kita kena consider. Dia dalam bentuk macam itu. Okay, so we can see that x equals to 0, 0, 6. Because y coordinate juga kena sebab dia ask for the relative extremum points. Soalan dia ada point. So dia mesti ada y coordinate sekali. Alright, so 0, 6 is a relative maximum point. Boleh tak? Boleh faham tak, kelas?
Boleh.
Okay, so now we proceed to the next point. Tadi kita check x equals to 0. Sekarang kita check x equals to 2. Saya padam Sudah saling ke belum?
Dah.
Okay, saya padam ni. Then now, we will check the second point, iaitu x equals to 2. This is 2. Dy dx, sekali lagi saya cari. Saya dah padam dah tadi. When X equals to 2, saya lukis table yang sama. 3 row and 4 column. 1, 2, 3, 4. Okay, 4 column. Untuk tengah-tengah ini adalah title, X. Ini adalah dy dx punya tanda. Ini adalah pattern. Okay, you can write whatever lah, y ke apa ke whatever. Okay, so untuk tengah-tengah ni adalah X equals to 2. Masukkan. Nilai di kiri dia adalah satu nilai yang kurang daripada 2, tapi bukan jauh sangat. Okay, bukan jauh sangat. You boleh letak ataupun some of you akan nampak, okay, some of the people they will write like this. They will write X equals to 2 negative. Apa maksud 2 negative? Sedikit kurang daripada 2. Okay, ataupun saya terus tulis X kurang daripada 2. Tapi kena bear in mind that jangan ganti nilai yang sangat jauh dari 2. Jangan ya. Just ambil 1 ataupun 0 will do. Jangan ambil negatif 100, okay, negatif 50, tak mau macam tu ya. Jangan jauh sangat. Okay, then bagi kanan dia kita ganti satu nilai yang lebih besar daripada 2. Or some of the video or books you may see this. You may see they write X equals to 2 positive. 2 positive meaning that apa? Sedikit lebih besar daripada 2. Contohnya 2.5 ataupun 3 ataupun 3 tu sebenarnya adalah jauh sudah consider okey lah ya nak ganti 3. Dan jangan gantilah ya 10, 20 tak mau ya. So, ganti satu nilai yang lebih besar daripada 2 dan dekat dengan 2. And after that, I will find my dy dx sign. Ini for sure is kosong. Because s equals to 2 is solved from the dy dx equals to 0. Kita dapat daripada sini. Confirm is 0. So this pattern confirm. Sudah kita boleh confirm is a horizontal line. Substitute a value which is less than 2 ke dalam. Ganti less than 2. Contohnya ganti 1. Ataupun okay, ganti 1 lah. 1 dapat 3 tolak 6. 3 tolak 6 dapat negatif. So here I got negative. Ganti satu nilai yang lebih besar daripada 2. Contohnya kita ganti 3. Ganti 3 ke dalam dy dx. 3 kuasa 2 dapat 9. 9 3 dapat 27. 27 tolak 18. Okay, dapat positive. We get positive. And what is the pattern? Pattern, if your dy dx is showing the negative sign, means that it's going down. Y is decreasing. If your dy dx shows the positive, meaning that your graph is increasing from the left to right. So if according to these 3 lines that we produce, we try to sketch a curve according to these 3 lines, you will have the shape like this. So can you tell me that x equals to 2 ini, dia berlaku pada relative maximum ke relative minimum?
Minimum.
Yes, very good. So you can say that this point, which is a 2, 2, 2, 2 is a relative minimum point. Okay, it's a relative minimum point. So kita test point by point. Okay, kita test point by point. That ini adalah first derivative test, meaning that kita check tanda bagi first derivative, iaitu dy dx. Kita check tanda ini dan kita cari pattern dia. Daripada situ kita consider dia adalah relative maximum ataupun relative minimum. Okay. Sudah salin ini? Sudah? Can I proceed? I proceed to the second derivative. Padam na? Okay. For the second derivative test, I will find dy dx. I think second derivative test dia lebih senang lagi tau. Tapi you kena tahu both. You need to know. You need to know both method because question may restrict method. Dia boleh tanya, okay, by using whatever method, okay, cari ini. So you kena pakai cara itu juga. First, get your dy dx to use the second derivative test. First, kita dapatkan dy dx dulu, iaitu 3x square tolak 6x. And then cari d2y dx2, the second derivative, you get the 6x minus 6. Then kita akan test titik 06, okay, when x equals to 0. Bila x sama dengan 0, d2y dx2 sama dengan 6 darab 0 tolak 6. Dapat negatif 6, which is less than 0. Just now in your notes, when the d2y dx2 shows the value of negative, means that 0, 6 is a relative maximum point. Okay, so you buat conclusion macam itu. Second, ada titik yang kedua, when x equals to 2, your d2y dx2, ganti x equals to 2 tu masuk dalam d2y dx2, you dapat apa? Dapat 12 tolak 6. 12 tolak 6 dapat 6, which is a positive. Kalau d2y dx2 having the value of positive, then what is your conclusion? 2, 2 is a relative minimum point. Boleh faham tak kelas? This is a second derivative test. Hello? Is that okay? So far, so good?
Okay, madam.
Okay, ya. So this is second derivative test, ya. Ini adalah second derivative test. First derivative test, normally kita buat dalam table lah, lebih organized. Second derivative test, just consider the algebra, the sign of the d2y dx2. And then from there, kita just buat conclusion, dia adalah relative maximum ataupun relative minimum. Itu adalah cara dia. Okay. Okay. Then kita stop kat sini. Kita stop kat sini dulu untuk lesson hari ini. Lagi you all buat tutorial dulu. Zahira.